So
It's Twitter. I have a hard time believing that the brand will ever be truly changed, unless Elon comes up with something bigger than Twitter for the brand, and then
that's what I understand he's trying to do, though. So
I just don't see it.
Yeah, he's trying to do it. They're adding all sorts of things. Some of them come, some of them go. Some
yeah,
of them are actually interesting. Some of them have potential yet don't realize on it. Like the whole what's it called? The thing like where you have those live chats, audio chats. What's it called?
Oh, I don't remember what the brand name for it is, but I know what you're
hang
talking
on, my
about.
phone.
The
It's
problem is
connected
that
to
it
my
only
headphones.
works on
Like my
mobile,
computer's
which
connected
is
to my
No,
headphones,
they
and so
actually
it keeps
added
interrupting.
support for the web interface not long ago, but it's still pretty bad because you can never find the things that are interesting to you, and you, it's
Yeah,
kind of weird that you can't just go and find, say, this is going to happen in 2 days. Can you put it in my calendar or something like that?
yeah, Twitter Spaces. They call it
Twitter
Spaces,
Spaces, and it's
yeah.
kind of disappeared off of the main UI now.
which is
I
too bad.
see it sometimes, but yeah,
They could have resurrected Clubhouse, because I know, well, I believe he was invested in Clubhouse, but
Oh, yeah.
Clubhouse turned out to be a scam. It was just a white label of a third-party messaging tool, and all the stuff they said about peer-to-peer and all that was completely fake.
Okay, although at the end of the day, nobody really cares about the technology as long as it kind of works.
Well, I mean, if you're told that this is some sort of private
Which is
chat
which is a
built
funny
on
thing to
a
say ahead of our current podcast today.
all right. I'm
Indeed.
gonna copy and paste the link to the Twitter stream here.
all right,
Oh,
I'll retweet it.
I put it in the comments. I shouldn't have done that. Oh well.
I think it's going to be fine.
By the way, I'll give you a heads up that ahead of our recording today, I had AJ find me the link that he previously sent to me. Jordan,
Oh, no.
Jordan, how does he spell his last name? Walk,
Nope.
Walk.
Oh,
Walk.
Uh-huh.
Yeah. With it
Jordan
walk with an E.
Walks Talk React to the Future, because I thought that it was interesting in the context of speaking about a compiler in the context of React. If you recall, in that talk, he's trying to convince everybody to just drop JavaScript and move over to Reason.
Oh, the good old days.
yeah. There's a. I don't know what kind of mixed company we're in, but there's a special place not in my heart for that talk.
I actually think it's a good talk.
The
Anyway,
presentation
we-
is a good presentation.
we-
The
we di-
blasphemy.
We
is what gets
digress,
me.
and
Yeah.
and did you post the thing, Chuck?
I did. I put it in the chat too, so you can just
So
go
it-
find it and retweet
It
it.
just
Okay, so we're
it
so
just
just
says-
guys, so you know, we're live.
All right.
Yes,
it
we are
just
live.
says special episode. Do we want to correct the title on that? I think you've got a couple
Nope,
minutes.
it's too late.
Oh, you
I don't think I can change it once we've started.
okay? All right.
So people will have to be intrigued and come see what we're talking about.
I will repost it with a quote tweet with the title that we want this to have, which is
React compiler.
I was gonna say React compiler something.
Joe, remind me, what's your X Twitter thing?
EN_JS.
And yours? How do you pronounce your name first? I have to ask.
It's Satya.
Satya. Okay.
My X handle is _G Satya.
and hello to everybody tuning in. Welcome. Nice
Yeah.
to have you. Hopefully,
Yeah, we're up
nice
to
be
17 so far.
had. Shh! Don't reveal the numbers. That's the secret. You keep them guessing.
Go tell your friends. All right. I'm going to get us rolling. And yeah, we'll just dive right in. Hey, everybody. Welcome back to another episode of JavaScript Jabber. This week on our panel, we have AJ O'Neill.
Yo, 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 coming at you live from an 800cc engine. Not really, though, but I am looking at getting a motorcycle.
All right, Dan Shapir.
Hi, from a warm and somewhat muggy Tel Aviv.
I'm Charles Max Wood from Top End Devs. This week we have two guests. We have Satya. I don't see your last name, so my friend, you're going to have to tell us who you are.
Hi, I'm Satya Gunasekharan. I work on
I was just going to say that.
Honestly, Microsoft getting Satya as their CEO is the best thing that has happened to me.
Right.
Because now everyone can pronounce my name, at least in tech.
All right, good deal. We also have Joe Savona.
Hey, great to be here. Thanks for having us.
Yeah, it's been a while since we've had you on. I don't know who's clicking on moving all the images around, but it is distracting me terribly. So I'm going to ask you to not do that anymore, and we'll just... Anyway, so yeah, Joe, I went and looked. I'm pretty sure we haven't had Satya on before, but you were on in 2015. We were talking about Relay and GraphQL. So welcome back. It's been a while.
Yeah, and last year for RSC.
Yeah.
Oh, my search did not find me
one.
that one.
Yeah. We spoke with Dan Abramov and Joe together about React.
You're right. It just doesn't have your name in the title.
Because
it's
Dan
fine.
sucks all the oxygen out of the room.
Yeah, exactly.
It doesn't have Dan's name in the title either, but that's neither here nor there.
We'll blame it on Dan, though.
Yeah. He's not here. Yeah. All right. So we're here to talk about the React compiler, and there was a big announcement, I guess, within the last week or so. I'm sorry. I'm in this time crunch where like time dilates, and so I don't know if it was 2 weeks ago or 2 months ago, but I know it was recent. So do you want to fill us in on what we're talking about today? Just kind of set the stage, and then we can dive into what it means.
Yeah, Satya, do you want to, as you take a sip of water, I'll punt it to you.
Sure. We had ReactConf a couple of weeks ago,
right,
where we announced the open sourcing of the React compiler, which we've been working on for almost 2.5 years, 3 years at this point. So it's been a while. It's open source. You can try it today. There's a Babel plugin that you can run on your apps, your React app, and it gets automatically memoized. So you no longer have to think about use memo and use callback and React.memo. The compiler helps remove the malmemoization. And then there's also an ESLint plugin that helps you catch bugs. So when you violate the rules of React, the ESLint plugin will help you so you can write bug-free React code.
Okay, I'm confused. In what sense do we mean... I really am. So first of all, I'm not a front-end person. I do mostly server-side. Okay, so when I think of a compiler, I think of like either compiler or transpiler. Transpiler, the way that React currently works, where you do an amalgamation of HTML and JavaScript and it compiles or transpiles to JavaScript, or a compiler is something that produces bytecode or machine code. So when you say compiler, it's at first it sounds like what you're just saying, like what I already know about React. There's a thing that transpiles some code from one thing to another, but then you're introducing it, which means that it's not what I think it is.
Yeah. So, before you guys answer, I actually have to interject and say that I got into a little bit of trouble, I think, with some members of your team when I stated on X, that I don't actually consider it to be a compiler, because while technically I understand why you're calling it a compiler, because it works like a compiler and there's ASTs and whatnot. It's taking JavaScript and valid JavaScript and translating it into valid JavaScript. So usually
JSX.
No, it's not about the JSX. It's about taking
You also support
JavaScript.
JSX and
Yeah,
TypeScript and Flow.
obviously, and also TypeScript, I guess. But
Yep.
but at the most basic level, it's taking perfectly valid JavaScript and translating it into perfectly valid JavaScript, which doesn't sound like what compilers are supposed to be doing. They're supposed to be taking stuff in language X and transforming it into language Y. But then, people told me that I was nitpicking, which is, probably true because I'm a nitpicker. But be that as it may, now I let you kind of answer AJ's question.
Right. So generally, like in the front end ecosystem, there's been Babel, which we use to do transformations on the AST, right? That's honestly how, or like why the term transpiler became popular, at least in the JS community, is the transformations using Babel. But I think in that aspect, yes, the React compiler is a transpiler. That is a source-to-source transformation. But the kind of analysis and how the compiler actually works is way more like a traditional compiler, like how V8 would work, which is why we call it the React compiler. We do lower it to not just AST, but to like very low level IR, and then we compile that back to source just because we want to ship that as JavaScript.
So, for the benefit of our listeners and myself, what's IR and then what's AST?
Right. So generally in a compiler pipeline, the source code is the first step of the compiler pipeline is converting the source text, which is JS syntax, into abstract syntax tree, which is like a tree of nodes which has some semantic information about your input. And you can do a lot of analysis, transformations on this, and it is pretty powerful. But there are some limitations to this data structure because it's a tree. And then generally compilers lower this to another data structure called intermediate representation, which is most generally a control flow graph. So it's more like a graph rather than a tree of nodes. So you can do more advanced optimizations and analysis on this data structure.
So what's the nuance between tree and graph? Because when I hear the two, normally they're synonymous.
One is cyclic, and the other isn't. Both are
Okay.
not.
Yeah.
Yeah,
Or
so
a tree is directed. It kind of goes one way.
Yeah, a tree is a kind of a graph. Like every tree is a graph, but not every graph is a tree.
Right.
Got it.
Right. So the React compiler does lower to this sort of lower level IR, which is like a graph, which is why we call it a compiler.
So
Can I just add on maybe?
yeah, go ahead.
Yeah, I would just add. So I think, well, first off, transpilers are a subset of compilers, right? And in the ecosystem, if you look at, if you go to Babel's homepage, they say compiler.
Unpicked
You go,
that nit. Very
you
nice.
go to TypeScript. They call it a compiler, right? So part of it. So it's kind of two aspects. One, the way it works is a compiler. The other aspect is naming it in a way that developers actually understand what it is, which is when you look around, similar types of things are in the JS ecosystem known as compilers, and this is doing something similar or actually more sophisticated in a lot of cases than what we've seen before. So I think like really to understand why we're calling it a compiler, it helps like get into what it's doing, right? It's not just about the fact that we're lowering to an IR and a control flow graph, but it's really about like what is the compiler doing, how does it understand your code, what transformations is it applying in order to help you have write nice clean job React code like you're used to and get better performance at the on the output. I think once we kind of understand like what it's doing in the full pipeline, then it becomes clear why we're calling it a compiler.
Yeah, I want to jump in here real quick because it feels like you brought me this sweet ride, and you're telling me what makes the pistons go up and down. And what I care about is how it's going to get me down the street so that I can go to the grocery store.
Exactly. What matters is not, yeah, exactly.
So I'm going to ask, why do I care? Right? What does this do for me?
That's a great question. Yes. Satya?
Well, do you mean like the why we have the compiler, or
Yeah, basically. So, I'm writing this awesome React app. Maybe I'm using Next.js, or maybe I'm just, hey, look, I do Rails, right? So maybe I have an API and I'm just doing React off of the API. But at the end of the day, how is it going to make my app better? How is it going to make my life easier? How is it going to make my users' life easier? Or does it not do any of those things, but I care about it for a completely unrelated reason?
Right. So what we've found out is React can sometimes be too reactive in that it can re-render more than necessary. And to fix that, and re-rendering too much can be a performance issue in certain cases. And to fix that, React gives you APIs like use memo, use callback, and React.memo. But using that is a mental tax for developers because they have to think about something other than building UIs, right? Like you don't want to be thinking about memoization. You want to be thinking about solving your user's problem. So the compiler comes in, automatically adds all of this to your app.
I like to say, and I would like to interject here a little bit, that first of all, I have to say that even the term re-render was confusing, at least for me, for a while, because you can think about two levels of rendering or re-rendering going on in the context of React. One level is the generation of the virtual DOM. When your code, the React code that you wrote as a React developer, runs and builds the virtual DOM. And then there is another rendering that happens when React itself takes the virtual DOM and transforms it into updates to the actual browser DOM. Now, from my perspective, from almost day one, or essentially from day one, you kind of solve the performance issue around the lower level re-rendering. That's what the virtual DOM was created for, the whole reconciliation mechanism.
Exactly. Yep.
There are some interesting things going on with Million.js. I know, for example, they're trying a different approach, which might be beneficial in some cases. But at the end of the day, it's solved and very efficiently, in most cases, by React itself at that lower level. The place where we still had a problem, turns out, was at the higher level of creating the virtual DOM. Because initially, when React was pitched to us way back, like almost a decade ago, essentially a decade ago, we were kind of told that, hey, virtual DOM is really cheap. It's just JavaScript objects, they're lightweight, there's little or low effort related to it. The browser is really good at managing JavaScript objects. Turns out that in some cases, you guys were lying.
Well,
I'm kidding.
Oh,
I'm kidding. I'm going to interject there just because.
I'm kidding.
Let's clarify.
I mean, yeah. I know.
But,
sorry, go for it.
Yeah, I think what has changed is the size and complexity of applications.
Yeah, for sure.
So you're absolutely right that there's kind of these two levels of rendering happening. There's the JavaScript React rendering, calling component functions, right, and then the code that they call, and then there's that creates a virtual DOM, and then there's React then doing the diffing of the virtual DOM. And you're right. So React has really solved that. Actually making the minimum number of DOM modifications, right? That's always been React's strength. But what's happened over time is people are building larger and larger applications with this more and more product code running, right? That high level rendering, and so that is where the time is really coming from. So I think the community focuses a lot on time, kind of time spent in the framework. But what we see in practice is that most time is spent in user code and in the product code. And so where the React compiler is really helping is in making it so that we only run the minimal set of product code that we need to when state changes, right? And then that complements the lower level piece of only making the necessary DOM modifications.
Yeah, and again, in this context, first of all, I have to say that I love React. So, if it comes across as if I'm being critical, it's criticism from love.
We appreciate good criticism. No,
is that what you told your kids too?
Yeah, actually, yes. I've been using React since 2014, so I'm really a long time React user. I think one of the first actually outside of Meta itself, and so I'm really appreciative of that. And I was even teaching React for a while. And when I was teaching React, one of the strengths of React that I was trying to convey was that whole pure approach of transforming state into UI. And that in an ideal world, if it was possible, we would be re-rendering everything from scratch on every change, just to make everything like stateless, as it were, like as pure as possible, state in, UI out. But reality gets in the way, and that's why we have all the sophistication behind the reconciliation in the virtual DOM to avoid the excessive DOM updates. And from my perspective, the React compiler is kind of like the final step, the filling in the missing link in this process. Because almost from the beginning, we've had to deal with all sorts of annoying things like should component update, and then replaced by memo and use memo. Maybe I'm forgetting something in the middle. And now, ideally, hopefully, we can finally forget about these things. Hint, hint, React forget.
Yep, that's cool. We couldn't have said it better. Yeah.
So can you now, so the benefit really, and that goes back to Chuck's question, I think, is the fact that your app becomes potentially significantly more performant without you needing to change anything.
Yeah, exactly. Right. It's that UI as a function of state. That's the thing that we've really seen that makes React so approachable to everyone, is that you write your app as if it is going to re-render. The entire thing is going to re-render every single time, right? So the whole, like as Satya mentioned, it being like too reactive, it's like there's never a point if for example, if you kind of forget about use memo and dependencies, right? Just JSX is never going to like forget to update, right? If you just write regular React code without any memoization, right? All the values will correctly propagate into your app. So it's kind of fully reactive by default, and it's really hard to kind of mess that up. The only places that you can mess it up are when you start getting into, okay, let me write a use memo. Oops, I forgot a dependency. And so now something doesn't update, right? So, and so it's by having the compiler do the memoization for you, we can make it so that you keep that same mental model of just writing simple functions, pure functions of mapping state to UI. And you get that same mental model, but under the hood, only the minimal parts of the code are actually running that need to.
So can I clarify a couple of things? First of all, it's, I'm going to back way up and then kind of come forward. But before I do that, the first thing that I want to just highlight is you're telling me that basically you put a better engine in my car and I don't have to do anything special other than upgrade React in order to get the more horsepower, right? I don't have to turn anything on or jump through some hoops or whatever, right?
Yep, that's the idea.
And then
obviously it's still experimental, so
right.
like maybe keep driving with the current engine for right now, try it out, give us feedback. But yeah, the idea is that that's what we're going for.
That's good to know, because then I don't get frustrated by it's not doing exactly what I expect. But the other piece of it is that you talked about kind of the two layers of DOM manipulation or compilation or whatever that React already did to react to changes. And it sounded like you were saying that you've optimized the one layer, but because of the way that it's optimized, right? So you have this is the stuff that needs to go on the page, and then this is how we're going to manipulate the virtual DOM to get it on the page. You optimized this layer with the, putting it on the virtual DOM, or did I get that wrong?
No, you got it reversed.
I got it reversed? Okay.
From the get-go, the mechanism that got the virtual DOM to the DOM was highly optimal. It identified what changed in the virtual DOM.
Oh, right.
And then updated did only those things in the DOM that actually needed updating. And to be honest, that's the most expensive thing per update, because the DOM is expensive. But what was missing was the optimization to the user land code that generated the virtual DOM itself to, the higher level.
Okay. But because you've optimized, I guess I had one layer here, one layer here. Because you optimize this layer, it translates into better performance here because it doesn't have to do as much work.
Yeah. So yeah, exactly. So React has actually always had an optimization that most developers don't take advantage of, which is that when you return some JSX from your component, we compare the basic idea of what React is doing in order to find the minimal DOM updates is reconciling. Okay, you returned this new JSX telling us what the UI should be. We're going to compare it to the previous JSX, what the UI was, and we're going to figure out the difference. And so one of the built-in optimizations there is that if it's the exact same JSX element at a particular point, we can say, okay, that entire subtree doesn't have to change unless it had its own like state updates or something. But we can just kind of skip that subtree and look at the rest, right? And so what the compiler is doing is taking advantage of that and kind of finding all the bits of the JSX that don't need to update. We're not passing a new prop to that component, so we'll just reuse that entire JSX element, and now React can actually skip diffing that element. So it's actually doing less. It's doing less rendering work, but it's also then creating less work to do in the diffing process as well.
I'll get back to that, because that's a really interesting point that I hadn't thought about and hadn't considered. But I think, since a lot of the optimization is actually based around memoization, I think it might be worthwhile to spend a couple of minutes in explaining what memoization actually is and what it means.
Yep. Yeah.
Yeah, I can do that. I think the main problem that we're solving with memoization is JavaScript's referential equality. Is if you create two objects and compare them, they're not equal, even if they have the same values in them. Only primitives can be compared. That's the problem that breaks down with this diffing that Joe just talked about. So with memoization, we keep, as long as the values don't semantically change, like the values in them don't change, the objects are the same.
So basically, you're saying if I have a function, let's say a pure function, to make it simple, that takes a couple of parameters, does some computation, and returns a result, I don't need to run this function again if the parameters haven't changed, because there's a guarantee that the result would be the same.
Yep.
And by remembering the previous result, not only am I avoiding the computation of running the function again, I'm also gaining the value of referential equality, because I'm using the exact same output value reference.
Yep.
So I don't need to do a deep comparison on the result. I can just look at the actual reference. So I benefit twice, as it were, from avoiding this recalculation.
Yeah, and there's a cascading aspect to this, right? So if you imagine that state changes, you update state and you change a count from 0 to 1, and then you put that count inside of an array for some reason, right? And now every time you render that, we're producing a new array, and now you use that array for some other calculation, and so now you're looking at, okay, right? So you started with just a single number changing. Now you've put that inside of an object or an array. Maybe you then capture that inside of a function, right? To log that array. And so without memoization, what's kind of happening again, like the default in React, just every time we render, we produce a new state, new array, new object capturing that, new function logging it. With memoization, the idea is to say, okay, if the input didn't change, we're going to produce the same output. But now, if you kind of only do that at one step, it doesn't really help, right? If you say, oh, like if the array didn't change, don't produce the new function. Well, the array changes every time, so that didn't really help, right? The idea is that with memoization, it needs to kind of be every single step of the way, or else you get a cascade. If you forget one step in that process, now that will always produce a new result. Now the next stage that is trying to memoize will say, oh, well, my input array changed. What am I going to do? I guess I have to recalculate and reproduce this function or something. And so then you get an entire subtree kind of unnecessarily updating. And so the idea is that with memoization, one way to think about it is automatic memoization. Another way to think about it is kind of tuning the amount of reactivity. What we're doing is making it so that when values semantically change, we're updating, and otherwise we're not updating. So that's the thing that Satya is trying to get with. Like, I think that the point you're getting at with referential equality, right, is referential equality is kind of a stand-in for did this meaningfully change, because that's the only kind of way we have to kind of to check did it meaningfully change. Otherwise, you actually got to do a full diff of the object, and unfortunately, you can't diff functions in JavaScript.
Yeah.
So right, we're kind of just limited by the language there.
So just again to clarify to our listeners who might not be familiar with the terminology, let's say, when you're looking at a primitive value like a number or Boolean or even a string in JavaScript, you're just comparing it and JavaScript does it for you. So, 7 is equal to 7, hello is equal to hello. But when you've got a reference to an object, there are two types of equality here. One is that we've got two references to the exact same object, and the other is that there are two objects, but they are equivalent. They have the same values for all their properties. And again, it might be it's whether you go through that object recursively or just one level down. The problem obviously isn't that simple. So the easiest thing to do in JavaScript, because that's built in, is referential equality, which means that both variables are referencing the exact same object. Then you just use a comparison operator and it works. But if you want a value comparison, you need to do some sort of a deep comparison, like the low dash is equal, for those of us who remember that. And
Yep.
It's expensive because it goes recursively through the object and it has to safeguard against cyclic links and stuff like that. It's not cheap.
Yep.
So what you're saying is when I memoize, then I'm guaranteed not only to get the result, which is the same object in terms of its values, I'm guaranteed to get the exact same object instance. Hence, I can use the very cheap referential equality that's built into JavaScript.
Exactly. Yep.
Now, one more thing before we move on from there. Again, if we go back to the existing primitives that are in React, we've got memo and use memo. Can you briefly explain what they are and the differences between them? Because I gather that the React compiler effectively replaces both.
Yeah. So React.memo is to wrap your component. It's so that as long as your props don't change, the component doesn't re-render. The default behavior in React is if your parent re-renders, then we re-render the child component, even if the props don't change. So that's the React.memo. And use memo is if any of the dependencies of the use memo change, then rerun a computation. Otherwise, reuse the cached value of computation that the use memo is wrapped in.
And I have to say that, again, as a long-time React developer, I've encountered a lot of code where somebody added use state to a top-level component that for some, maybe let's say some button click or something, and then that thing causes a re-render of effectively the entire application for no good reason. Right. So the fix against that was to use, and ideally you could do two things. You could either move that button into its own subcomponent, which it's easy to do, but sometimes felt like, unnecessary overhead on the developer. Right. The other alternative was to memoize all the subcomponents, but then people either memorize too much or too little, and when they memorize too much, they showed wrong things, and when they memorize too little, then they didn't get the performance benefits. And what I actually often see is that in many applications, either they don't memorize anything, and they often don't even realize that they have a problem because, it works. It's
Right.
kind of slow, but it works. Or they memorize everything, and the whole application is just a million calls to memo.
Yep, that's exactly the type of thing we've seen. And to be clear, like a lot of times for especially for smaller applications, the fact that there isn't a lot of memoization is fine. Like the amount of re-rendering that you're doing just can be fine. It's funny, like I think we hear a lot about the places where people run into performance problems, but we don't hear about the cases that are basically fine. And so, one of the things at ReactConf that was interesting was just going around and talking to people, and people are saying like, oh, I love React. It's so fast. I never have performance problems. It's like, oh, that's so nice to hear. But like, we're not content with that, but it's still great to hear, right? We want to make every React app fast by default. But yes, the need to do this kind of memoization, that is overhead that we can solve, right? That's like that, having to kind of, and the worst part is that if you add, you could go through a lot of trouble to add memoization everywhere, but it's still easy to miss, one spot, right? And then and as I said, like that can then cause a cascade because you missed one memoization, so that produces a new value, and then that new value flows into the memoization you have, which then says, oh, my input changed, I have to recalculate, and then that kind of causes a cascade. And so missing a single memoization, right, can kind of defeat all your optimizations, and that's very easy to have happen when you're changing the code over time. You were passing one callback and you memoized it. Now somebody adds an extra callback and they forget to memorize it, and oops, there you go. Right.
So am I correct in understanding that essentially what the compiler does is it goes through all of your code, find all the places where you should have put memo or use memo, and then implicitly inserts them for you? Does it also do other things, or does it do something different, or what?
It's like automatic semicolon insertion, except cooler, right?
Good analogy.
Well, that actually brings up the point that I wanted to ask is, it seems like this is the type of magic that we need, but why not put it in the hands of the user like, a linter? For me personally, I prefer explicit over implicit, and I prefer to work with the fewest layers of abstraction, because you can't understand. There's too much abstraction in modern software. Jonathan Blow and Casey Moratori and all these guys are talking about this stuff, Primogen, etc. The abstraction has become so great that people they have no idea what's going on. But we have a lot of great tools, but what if we could just surface it at the user level, where it is a linter thing, or like an auto formatter thing, like automatic semicolon insertion, like, hey, you should use memo here. Or just like, I hit save and then boom, the use memo appears, and I change the code and I hit save and boom, the use memo disappears because it's not relevant. Like, if you've got that information, why not surface it to the developers so that they can learn and grow, and not be like pushed down behind more abstraction on something that's already like they're crushing under the weight of it?
I have my opinion on that, but I'll let the guys answer first, if they have an answer.
Joe, I'm actually curious to hear your thoughts. So.
Yeah. So I think there's okay, I guess I disagree with the premise somewhat, that there's too much abstraction. We don't.
What?
Yes.
That's not controversial. You broke me.
Right. So when you start your next project, you write your own database, your own operating system, you implement your own programming language, you write your own text editor, you write your own graphics engine. You do all those things before you can build your next blog, right?
That was just last week. My whole week.
Yeah. No, I know that you're. I'm just like for the audience sake of like there's clearly like a certain level of abstraction that's kind of necessary. So to me, it's really about the value of a particular abstraction, right? Like, I definitely hear what you're saying. Like, there are some abstractions that don't pay their weight, right? And in particular, I think like the bane of like software developers' existence is like leaky abstractions, right? Where you're like, it almost works, but it doesn't always work. And that's, I think, where those are the
Well,
things that kind of can be too magical in debugging them. So go ahead.
Let me just to your example, I want to add something clarifying. VS Code to JavaScript file. Perfect. Like, this is a good abstraction. It's perfectly understandable that
Right.
it's one-to-one.
It's a non-leaky abstraction, right?
Okay. Microsoft Word to JavaScript. I mean, like, now you got to deal with the smart quotes. You got to do special pasting. Like, very bad abstraction. Good for a particular purpose, right? But, like, so there's a difference between saying, oh, like, because the editor you can perfectly understand. There's no confusion about what happens in VS Code when you hit save. Like, the file you get, it, like, so yes, there's a lot of abstraction there, and it might take 15 minutes to load, but once it's loaded, you hit save, like, you get the thing that you expected, and there's not, like, this burden of, holy crap, how did this file end up here?
Yeah. So the other aspect is then the question for me is, like, is it a leaky abstraction, right? Is the abstraction sound? Can you rely on it? Can you build up a clear mental model of what the compiler is doing? And that's what we've really focused on, right? So that's what we've really focused on. Model. So so there's kind of the mental model aspect and then the pragmatic aspect of, and we kind of have to balance these two things. So on the practical side, imagine that we did say provide a linter that would add memoization. In our analysis, we've seen, I don't know if I can share the number. The compiler adds a lot more memoization. Like, it memoizes things that developers would never in a million years have thought to memoize, right? Like, every single individual JSX expression getting independently memoized, and then attempting to be very smart about how it groups those together, right? Because it can figure out, oh, you're just creating JSX. And so, like, one of the things we're working on now is kind of starting to reorder the instructions. So we can say, oh, these three things all depend upon the same input. Let's recreate them together, because you as a developer can't observe when that code runs. So it's more efficient to group them together. Now, that, like, rewriting that, like, but that transformation might not be the most readable way to actually look at that code, right? So that's where, on the practical side, if we were to do this, the things we'd be suggesting to you as, like, here, go, change your code to be like this, that might not be readable, that might not be very editable. And so instead, letting the developer not have to worry about that. Not to mention, you go to edit your file and you're like, okay, is it safe to put this over here? Do I have to put it inside the use memo? Where does this code go? It's a lot easier to think about just writing your code the way it makes sense, and let
AJ, before you interrupt, again, based on my experience, and Joe was going exactly where I wanted to go, is the fact that memoization for me is a lot of line noise. Even if the compiler wasn't doing all the sophisticated things that Joe just described, even if it was just adding relatively simple use memo and memo calls without moving the code all over the place, all those memos and use memos don't really add anything to the business logic. There are a lot of line noise. So if I can ignore them, if I can remove them out of the code becomes clearer and more readable. Like I said, in the ideal world, everything would be just state in, JSX out, and you wouldn't need to worry and think about all these optimizations. Like, I don't have to think about the reconciliation. It happens for me. Likewise, I don't want to need to think about the memoization. Now, certainly, when you start moving code around and grouping things and changing the order of things, then it's totally a new ball game, and you don't want to be working at that level.
Yeah, well, I get that. I understand now. It's a very lossy conversion. It is more similar to a traditional compiler. It is doing the fun roll loops.
Yeah, one thing that it comes to mind, just from my background with Rails or this or that, right, is that you wind up putting a lot of stuff in to your code that is the bookkeeping stuff, and is not the, hey, this section of code has this responsibility, right? And if in my ideal world, if I'm looking at a class or a JavaScript function or something like that, or a JavaScript file, the only things I want to see are actually the business of getting done what I want to get done. And so to me, the appeal of this is I don't have to think about the performance management or the memory management or anything else, because that's taken care of for me. And so I can just focus on, I have a component that displays this data, or I have this business logic behind the scenes that when I get JSON from the server, it surfaces it in this way, because that's my job. My job shouldn't be, oh, I've got to go in and make sure that all the I's are dotted and the T's are crossed, because that's no fun anyway. And to be perfectly honest, the computer probably can do it better.
Yeah, I think memory management is a good analogy, right? Like writing something like C++ or Rust or C, like a lower level language, where you have to like
not my
malloc and free, right? Like that's low level details, and there are cases, where that is critical for performance, and there's definitely use cases for systems languages for sure. When we're writing, high level application with UI logic, that really just starts to get in the way, especially when we have these very, UIs are very dynamic, right? Like the lifetime of a value is very hard to think about, because okay, this thing's going to get shown based on all this parent context, and when does it actually should get it freed? It's way easier to just say let a garbage collector deal with that, and I think it's very similar with memoization.
Now I have a question. Like as we said, a lot of code bases already have use memo and memo inside of them. Now, ideally, I would think that once I move to a React compiler, I would literally go through all my code and just remove all of them. But that's a chore. So obviously, at least at the beginning, a lot of code will have memo and use memo inside of it. What do you do with that? Do you just leave it there? Do you effectively remove it, then optimize? Like ideally, I would think that you would essentially remove it and then optimize the resulting code.
That's exactly what we do. We ignore the use memos. We optimize it as though it doesn't exist. But we also check that, have we optimized it similar to what the user has optimized it? Like, are our dependencies different? Or is it less fine-grained than the user? If it doesn't match up, then we bail out. So we make sure we don't change anything and progress. And we only optimize and improve.
Oh, wow, cool.
Yeah, so it's actually, once we are out of the experimental phase, I think it'd be more safe to like remove the use callback for the components that the compiler can safely compile.
Oh yeah, it also takes care of use callback. I forgot about that.
Yep.
Right. Yeah. So one of the things that, but part of one of the things we kind of want to do during the experimental phase is get more, data from, this is why we're starting the working group to get more feedback from users about, okay, where is the compiler generally able to preserve existing memoization? Are there patterns where the compiler isn't able to preserve that existing memoization, and we should tune the compiler to be smarter about those cases, right? Because our eventual goal is to get to where users don't have to do manual memoization hopefully at all. But definitely in the experimental phase, we're probably not 100% of the way there, and so we kind of want to get feedback to kind of tune and get all the way to that point.
Now you mentioned bailing out. Can you elaborate a little bit about that behavior of the compiler?
Sure, yeah. So the compiler assumes the code follows the rules of React, right? Like there are certain rules that we expect, like props. You can't mutate props. You must use the setter function to update state. Things like that.
Hey, AJ, it's like the what's it called? The rules of Python and Go and stuff like that.
The Zen of Python.
The Zen of Python.
Go Proverbs, Zen of Zig.
So we have the Zen of React.
That's good. I need to update my link of things with the Zens, because I think I had. What do I have for that for React? There are two. The React rationale. There are two documents for React that I have in the list of the thingies.
Now I just feel like going and meditating on my components for a while.
So what are the rules? I'm going to jump us a little bit to the side because I have to. You brought it up, Satya. What are the rules of React?
I think the main one is keep components pure, that we already know. And all of the other rules just fall out of that which is don't mutate your props, don't update the state without the setter function, don't and then there are like certain like implementation rules, like don't call hooks conditionally, use have a use prefix for your hooks.
Is there a
things
list
like that.
somewhere like online?
There is. We have a really great documentation page on all of the rules with examples. We also have a ESLint plugin that will catch where you violate the rules of React and point to the documentation, I think.
Okay,
the
so
bailouts.
previously
Okay.
there was thinking in React, React design principles, and then there was a YouTube video, React Today and Tomorrow, that were the kind of philosophical documents for React. So I will try to find. Wait, you've got rules of React published?
Yeah,
I just posted the link to
Oh, you posted the link?
Facebook,
Okay.
YouTube, and Twitch. I wish X would do that,
update.
but it doesn't. But
I
it's
wish that-
for those that are watching live and are going, okay, how do I find this, or how do I go find the video? It's react.dev/reference/rules.
Yeah.
Okay.
Yep.
I'm putting it in the list.
The bailouts. Should I go
Right.
ahead? Yeah.
So when the compiler actually has validation to know and figure out if any of these rules are being violated, and if they are being violated, then it doesn't compile the component, because it could incorrectly compile the component if you don't follow the rules. So that's how we classify. We want to be safe, and we want to only optimize if we know it's correct. That's the idea behind having bailouts.
Yeah.
That's the thing I really love. Sorry, I apologize, Joe. Just I have to say that's the thing I really love about React compiler, and kind of like one of the big differences if I'm comparing to other React technologies, like for example React Server Components, is the fact that you took an approach of being like very low resistance, hardly any resistance at all. Basically, you drop it in. If your components are compatible with it, you just gain the benefit. If they aren't, nothing bad happens. Again, obviously, as you said, it's experimental, but I'm saying once it's released, that's how it should work. And that to me is just, it's just upside and no downside. You don't need to re-architect, to change stuff. You just gain immediate value.
Yeah, and I think it's more than like, yeah, that's been a really pretty critical piece of this project. Is we don't want to have to change the way people write React code. We want to just have something that works out, as much as possible out of the box. That has always been the goal. To be clear, there are some ways that you can violate the rules of React in ways that the compiler doesn't detect. The canonical one is like put the violation behind a function call, like write some helper function that like flagrantly violates the rules and call that function. And so for example, like modify state inside of a helper function. We don't know that yet.
Proxies,
right? But like as much as possible, right? We detect that you're following the rules, and in general, if you're breaking the rules, you will often see that pop up as a bug, right? Like you go to add use memo to something, and all of a sudden it's not updating as you'd expect. Oh, it's because you have some bugs. So these are things that you could have run into at any time that we're helping to detect. We're also working on tooling to kind of. There are some things that we can detect statically. There are others that can only be detected at runtime, and so we're working on some tooling to help kind of at runtime, right? Kind of like even like almost like further than strict mode to help figure out like, oh, the inputs to this value didn't change, but the output did change. Why is that? Oh, it looks like you might have a bug, and we can help to pinpoint. So we're using these tools internally as we roll out the compiler, and we're hoping to bring those to open source as well. But the other thing is, we called this React compiler for a reason, and that it's not just about auto memoization. This is really, it's really two features, right? It's for right now, it's auto memoization and the linting. But this also it's really a platform for understanding your code and being able to change the way it runs, what's happening at runtime to be more optimal. So we're also looking at like, okay, what else can we do? What other APIs can we provide where we can rely on the compiler? Like, do we need a new API for something, or could the compiler just do that automatically for you, right? So for example, a lot of folks have asked about context selectors, which the idea there being sometimes you only want to access a small piece of context. And right now, whenever the context value changes, we have to render every component that uses that context value. So for example, a common case is like routing, right? Maybe the one query parameter changes, but a particular component only cares about like the domain. The domain didn't change, so why should we re-render the component that cares about domain when the domain didn't change? And so a lot of people have asked for context selectors to say, oh, let's help us target the updates to the components that where their actual input data changed. Well, okay, we could provide an API for that, and the developers would have to adopt it, remember to use it in all the right places, or we could say, let's have the compiler do that for you, right? And so the compiler gives us, a kind of it's a powerful lever for making it so that developers, we can just optimize things out of the box without developers having to think about it. So I think this kind of builds on that. Like once you have this solid foundation, we can kind of level up from there.
One thing that I would love to have, I don't know if it's on your roadmap at all, would be automatically generating the dependency map array for use effect.
Yeah, this is something we're thinking about actively, but it can be tricky. There are some valid use cases for not having all of the dependencies in the array, right? So we're thinking of new APIs, and yeah, in general, we're thinking about.
Alternatively, if somebody, I think these days you have to explicitly specify a dependency, at the very least an empty array. So maybe like in a scenario, if no array is provided at all, instead of treating it, as a runtime bug, you would transform it into the correct array, as it were. I don't know, just a thought.
Well, that's back to the point I was trying to make earlier, right? There's no value to having the dependency empty array, right?
Well, no.
If it's not there, then you would also assume it, and yeah, then you have less clutter in your code.
Yes.
Yeah. So basically, I think this really gets to the question of what are effects for, and use effect is kind of Dan wrote a great a series of posts there's all on the documentation on the react.dev doc site about you might not need an effect. There's a lot of things that people reach for effects for that actually have other solutions. So part of it is kind of identifying, okay, where should you just not be using an effect at all? For example, sometimes people will do an effect where they'll kind of look at the prop, they'll keep some state, they'll look at the prop, and if the prop changes, they like reset. It's like, well, they're basically doing use memo, but manually with a second render. It's like, okay, just use memo there, for example. Or with React compiler, you don't even need memo at all, to do anything at all. There are a couple of really, really good use cases for effects. One is kind of creating sort of custom events like on mount, right? Like use effect lets you do a sort of on mount type of event. And another is synchronizing React state to some external system. And so what we're looking at is kind of really understanding these specific use cases where you really need an effect, and then crafting the API there. But I think what Satya is getting at about you might not need an effect, is that when you're writing an effect, there really are like legitimate use cases for not listing all the dependencies. And the problem today is that because what you'll do is you'll add the dependency array, you'll list out a couple dependencies, and then I want to skip that one, so you'll do an ESLint suppress disable rule, like tell the React linter to stop talking. The problem is now you mentioned some other value, and by default we don't catch it. And so I think that's a case where we need a better API to say, no, I want to explicitly ignore this one value, but other values should get automatically captured. So this is the kind of stuff we're thinking through. It's like we're definitely working on it because we understand that we want to do better on effects.
So two things about that. First of all, when you disable the rule, you usually disable it for the entire line, which means that now if you make other mistakes in that line, they actually won't get caught.
Exactly, right.
So
that's the problem, right?
Yeah, that's problem number one. And problem number two is that if you're doing it, you're probably doing it for the wrong reason.
That is another, yes, exactly, right. But there are legitimate use cases for doing that, and that's something that we really want to work on a crafted API for, to like help developers really understand, like, did you mean to do this or did you mean to do that other thing?
Now, you were talking about the fact that it's not just a compiler, it's also a linter. And whenever you bail out, there are appropriate linter messages. Even, I guess, when you don't bail out, you might provide informative linting messages. To me, that's almost as valuable as the compiler itself. If I have like a React expert watching over my shoulder, making sure that I'm writing the code according to the rules, that's a lot of benefit, especially for smaller teams, more junior developers, etc.
Yep, absolutely. Yep.
Yeah, well, and I like the you may cause problems, right? It's not just a hey, this is we prefer two spaces instead of tabs, right? It's hey, this may actually surface bugs.
Now, you mentioned something a while back at the beginning of our conversation, which kind of piqued my interest, and I wasn't sure if I was understanding it correctly or not. But there's an interesting potential for passing data, as it were, implicitly from the compiler, from that static analysis that compiler does, to the reconciler, like kind of behind the developer's back. Like, is that something that you actually do or thinking about? Is there any potential value in that, or am I just overcomplicating things?
So can you describe a bit more about like what you mean there?
Well, theoretically, you could create some sort of, associate some, I don't know, some hidden property to the object that you create, and that tells the reconciler to behave somewhat differently in certain scenarios.
Yeah. So I think well, we've kind of thought about a couple things in that general realm. One is that, well, we talked about how the compiler auto memoizes, but one thing to note there is that when we are talking about auto memoization, we actually don't add use memo calls. So there's we're actually like producing just like an if else block that's kind of says like, if the inputs to this computation have changed, recompute it, otherwise reuse the cached value. And there's other things that we can do where we can say, okay, the user wrote, for example, a use effect, but maybe the output of that doesn't actually have to be a hook call. Maybe it could just be something that does a more targeted update. So these are some of the things we're looking at around effects. But I think for the most part, it's what we're exploring is more, okay, once we have a really a deep understanding of your code and what your component intends, what the intended behavior is, we can start changing how that works at runtime more dramatically. So the compiler is kind of step one of, we have the existing React runtime. We're going to use a compiler to understand your code and kind of optimize with the current runtime. Now we have that baseline of compiler and runtime, and now we can start evolving them together to actually change the runtime and how the runtime works to be more efficient, knowing that we have this compiler to rely on, right? And maybe it means that if there will still obviously have to support, like if you have a component that violates the rules that we can't compile, we'll still need a way to support that, but we can start optimizing for it. If you do follow the rules, can we make that even faster? So that's kind of where we go next. But the first phase is just getting the compiler to be stable, obviously.
Now, another question is, currently the input is valid, well, React JavaScript or React TypeScript. And by React, I mean that it has JSX in it. But it's still effectively just JavaScript. Are you thinking of maybe, creating a React script further down the line? I mean, we kind of talked about it before the show started, that React's original creator, Jordan Walk, actually also created the Reason programming language, and ideally envisioned all the React developers not only embracing React, but also replacing their JavaScript with Reason, and hence solving all the referential equality stuff, because Reason is a function language with immutable data structures. So are you thinking of one day maybe, somehow, instead of in one fell swoop, like, gradually moving us over to a React script?
Yeah. So we think about we think about React very much as like a programming language. It has its own kind of semantics. For example, it has concepts like components and hooks that obviously don't exist in JavaScript. But we think that the thing that has made React so successful is that we embrace JavaScript. And so, while we think about the design of React from a programming language perspective, we recognize, for example, we meta open sourced Flow, which is a really great type system for JavaScript. The community has overwhelmingly really supported TypeScript, and TypeScript is an amazing language. We love it. The compiler is written in TypeScript, by the way, so huge fans of TypeScript as well.
Not in Rust, not in Go. How dare you?
I know. Well, we can get into the Rust question in a little bit, but yeah, we really want us to kind of support developers, meet developers where they are. Like, Tomachino, the former manager and director of React.org, used to say, always bet on JavaScript. And I think that's always, for us, that's always been a good bet. So yeah, while we think about React from a programming language perspective, I don't really foresee us creating a React script. We have been on the Flow side, been experimenting with some custom syntax for React. So this is like, specific to Flow. Flow is like kind of helping us explore what these first class concepts could be if they were in the language. But that is something that is purely optional. If you use Flow, you can opt into these like component or hook keywords. But really, React is always going to be about JavaScript and supporting JavaScript from that's our bread and butter.
Another point that I have to bring up, and we actually kind of answered that without referring to it explicitly, is signals. Basically, what I hear from a lot of developers is, why do I need the compiler to get these fine-grained computations and updates if I can just use signals instead and get fine-grained reactivity? What's your answer to that?
Well, the really simple answer is why rewrite your application to use signals when you could get fine-grained reactivity by just adopting a compiler? I think,
that's a great answer.
But the long version of the answer. First off, in case folks are not familiar with what signals are, right? Signals are the idea of basically building up a computation graph. So you write code that creates input signals. You explicitly create with APIs like a create memo or computed, right? You create you define functions where those functions are accessing other signals or other computed values, and then you kind of have either effects or kind of listeners sort of at the outside that are saying, okay, whenever one of my inputs changes, I'm going to take some action on the outside world, like log or update the text value of a DOM element or something like that. So you have inputs, derived computations, and then sort of outputs to the system. That's the rough idea of signals. But with signals as a first class API, your code is actually a kind of a meta program. You're writing code that is constructing a computation graph. That initialization code runs once, and then you have the computation graph that is actually running over time. And so you look at your component, and there's actually like two phases going on that you have to think about. And so you see things like, people talk about, like you can't destructure props, or you can't do this, or you can't do that. And it's because there are mistakes that are like easy mistakes to make where you're accidentally accessing a value at the wrong phase of the program, and now reactivity gets lost, right? You also have to think about a lot of the kind of signals-based frameworks will distinguish between a true memoized, like where you have a derived computation that's an actual signal versus something that's just a lambda that's kind of passing values through. There's actually a surprising difference there, where using an actual like a proper derived signal might allow you to get to short circuit reevaluation. But if you just use a lambda, you don't get that short circuiting effect. So there's a lot of subtleties you have to actually think about when you're writing a program in this way, that you don't have to think about when you're just writing UI as a function of state, right? So our kind of idea is, okay, one of the things that has made React so, I think so successful, and why so many people, are able to kind of ramp up on React and be productive. I have a friend who just recently learned to program, and like 1 week they're saying, oh, React seems really complicated. They just started looking at it, and then a couple weeks later, like, oh, I built a UI, like it works, it's great, like I love it, like I love use state, it's so easy. Like I think there's something that is very approachable and easy to understand about the kind of UI as a function of state, and then we can just take that and optimize it. So under the hood with React compiler, we're getting that same kind of fine-grained reactivity, but things like it's normal JavaScript values. You can do things like early return. You can destructure your props. All these things that you expect to work still just work because it's the same React, and just under the hood, it's working a bit differently.
I think that's really the key, and you've hit the nail on the head, that the key difference between the React way, I would call it, and the Signal way is a different approach of thinking about UI construction. So if I'm just looking at it from the perspective of which one is more efficient, which one is more performant, which one is, results in fewer lines of code, I'm kind of missing the forest for the trees. The key aspect is, how do I think about a front-end application design and architecture? Some people prefer to think about it one way. Some people like to think about it another way. I really like the React approach, and like I said at the very beginning, that in an ideal world, it's just, as you said, Joe, state in, UI out. The whole UI thing is just this effectively functional composition, and that kind of gets lost with the Signal approach, which is why when people tell me, hey, like, when is React going to get signals? And even though I don't work at Meta, so I can't really speak for you guys, I say, I bet that never, because it's just not the React way from my perspective.
Yeah, I will clarify that, just a bit. I mean, there is a proposal out to add signals as a TC39, to the language. Obviously, if that becomes a standard, right? Just like we've now have use to, and you can pass a promise and use promises in React. Obviously, we'd want to support built-in features of the language, and so we'd certainly provide a way to consume the value of a signal and read it in a component of, like, so obviously in that sense we'll support signals, right, if they become part of the language, but in terms of like using them as a core feature for how to do state management and updates in React, yeah, as you said, we don't think that that's really fits in the React way, and we think that the current React model of UI as a function of state, plain JavaScript values, normal JavaScript idioms like early return, if else, loops, things like that's an easier way to reason about applications, and that's where we expect to continue going with React.
All right, I'm going to jump in here because we're kind of getting toward the end of our time, and I want to be respectful of yours. But I guess, so earlier I asked, hey, so I don't have to do anything in order to use this. But it sounds like it's experimental, so I might have to, if I want to try it now, there may be some steps to trying it, or maybe it's just within the working group. So if people want to try it out, how do they do that? And then when... people hate when I ask this question, when do you think it's going to go to the general public, right? And then I get the, don't do me like that, Chuck. But, and I don't know if, it's like, well, barring any major hiccups, it's this, or, anyway, however you want to answer that.
Right. So I think, yeah, right now it is an experimental state. You can npm install the Babel plugin. It's super easy to add it to the Babel config. Just add the compiler,
Okay.
And it should just work. And we're still accepting more partners to the working group. We really want feedback from the community. We want to understand how people are using the compiler, how the compiler works outside of Meta, and get feedback, and improve the compiler to make it stable. I think as part of that, I think it's too early to say when exactly we'll make it stable, but I think it depends on the feedback we get from the working group. If the feedback is mostly positive, then it seems like something we'd make stable soon.
Yeah, just to add on, I think some of the things that we're thinking about are the getting feedback from the community, as Satya said. We are working on effects, and like that kind of like ties in a little bit to that work. The other big thing that we're looking at is what should libraries do. So, for example, if you're publishing a library and you want that library to be compatible with multiple versions of React, how should you pre-compile the library? Should you not pre-compile it? Our current recommendation is to pre-compile libraries, and then developers don't because the general thing is you don't compile your node modules, right? Like I compile my code with like the settings I want. You know the packages that I like that I bring in, like those developers know how, like, can transform their code based on how they wrote it, right? So you kind of leave node modules alone. That also makes builds faster, so it's kind of win-win. So rough ideas: libraries should publish pre-compiled code, but then one of the things we have to figure out is, okay, how does that work with like multiple React versions as the compiler changes over time, as the React runtime changes over time? So that's one of the things we have to kind of figure out, is really get a really solid strategy in place there so that everyone can start adopting it across the ecosystem.
Super cool.
One thing that I really missed, that I want to give a quick shout out to, is the health check script. So we have a script that will, like, if you just run npm React compiler health check, it will run the compiler against your code base, and it will like say, we were successfully able to compile X amount of components, found these libraries that doesn't work well with the compiler, so it'll give you like a status update. So we recommend trying that. Yeah, like Mobix.
And definitely, the ESLint plugin, also experimental, but I think, but that one, because it's not changing your output code, definitely recommend just like, there's basically no reason not to install that one, and then just give us feedback about it, because that's something that can really help you improve your code bases, starting today.
So installation is just npmi basically,
and adding it to the Babel config. Yep. Right, so npmi, cool. And then add it to your Babel config, add it to your lint config. Yep.
And we kind of ran out of time before we ever got to Rust and Go. So I guess we will just need to bring you on sometime again.
Give us a 2-minute answer if you want.
Yeah, the real quick answer is we know that people are moving to alternative build systems that are based in Rust and Go. Like ESBuild is awesome. SWC is great. There's OXC, Biome, right? A lot of exploration in the space, which is really exciting to see. So it does make it hard as a tool author trying to produce something. It's like, okay, how do we ship this? Like, because if we write it in Go, then it works in ESBuild, but it doesn't work in the other one. Right? There's kind of no like one way to write it. So we've started exploring porting the compiler to Rust, with the idea being that we can provide a node binding, we can provide a Go binding, we can obviously provide bindings to Rust-based tools. That is, we have a partial port that's in the repo, so you can go check that out if you're interested. But that is, unmaintained. We just kind of done an early exploration. Long term, I can imagine us, finishing that migration. But for now, it's based on TypeScript, so it works really easily. Drop in with Babel. Thankfully, most of the tools, things like Next.js, for example, Expo, we've already got documentation for how to use it in those tools. Even in, for example, Next, where the default build is using Rust, we can inject a Babel plugin into that process, and it just works.
Well, just be careful, because Rust is kind of old news, and Zig is the new hotness, and you wouldn't want to spend all that effort just to have to rewrite it again next week.
Yeah, I mean. Yeah, so what I would just say about that is Zig is a really cool language. It's got some really awesome features. We've on our team, we've had some great, like a lot of success with Rust. We use it internally for a bunch of different things, especially around build tools. Relay compiler, which I worked on, is now written in Rust. We rewrote from JavaScript to Rust a while back, and so we have a lot of familiarity on our team with Rust as a language. So that's kind of an obvious choice for us, in addition to the hype in the ecosystem.
Cool. All right. Well, I'm going to push us into the final segment of the show, which is our picks. Dan, why don't you start us off with picks?
Okay. I don't have a lot of picks, since this is the second episode we're recording this week, and I got, I kind of used some of my picks in our previous recording. So I've just got the one. I've been really on Netflix's case recently, with the quality of the movies they've been putting out. I said that the only good thing I could say about Atlas was that it's better than Rebel Moon, and I can't say anything good about Rebel Moon. So yeah, but now I actually I'm in the process of watching a Netflix movie which I'm finding surprisingly enjoyable and well made. And maybe I'll finish it today. I don't know, maybe so later in the week. It's Godzilla minus one. Now, it's really surprising to me because I really wasn't expecting much, and I'm not such a big fan of Godzilla movies. But this one is really good, at least again, the first half of the movie. And interestingly, it's good. The fact that it's good has nothing to do with Godzilla. The fact that it's good has everything to do with the uh, protagonist, the hero of the story, which is this kid who was a soldier doing Japanese soldier during World War II. He was actually a kamikaze pilot, and he kind of chickened out. It was really at the end of the war, basically like literally the last couple of days. Everybody knew they were losing, so he literally just didn't want to die, and he's living with the guilt. And there's the whole thing of Japan after the war, and the effect of the nuclear bombs, and like rebuilding the country, and walking around with the guilt of all your friends and family who have died, and you're alive, and stuff like that. And it's much more interesting and engaging to me than the actual monster. And that's why I'm enjoying this movie so much, and I would highly recommend it. Again, I'm talking about just the first half of the movie. I haven't watched the second half. And those are my picks for today. My pick.
Cool. AJ, what are your picks?
First pick is motorcycles, because my neighbor let me ride his motorcycle and I really liked it. And so I'm thinking about trying to find some old beater cruiser to ride around for myself. And if anybody's interested in getting a motorcycle learner's permit, it's a lot easier than the driver's license, because there's actually a national standard body called MSF, the Motorcycle Foundation. I think Motorcycle Safety Foundation, and they make the handbook that pretty much all 50 states use. So aside from, like, I don't know, Utah and Alaska that have a different BAC level, and like Arizona that I don't know, like aside from a very few niche things that vary from state to state, pretty much if you do any MSF practice test, you can go into your DMV and get your motorcycle learner's permit. And then the courses are standardized across the nation, called BRC for Basic Rider Course. And then they also have other courses. Like the BRC is, it basically, if you take the BRC, you can get your license without waiting whatever the time period is for your learner's permit, and without having to do the state exam, because the MSF exam will be done when you take the course, and it's more rigorous than the state exam. So you just take in your thing. So I'm getting my motorcycle license. So, as my wife, family, and friends would say, you may never hear or see from me again. See some quiet chuckles in the background there. And the other thing that I'll pick, a little self promo again, Webby is on the rise. I was just told recently that it is now an official install method for the GitHub CLI, and we're up to 1.7 thousand stars. So we have hit the inflection point. The line goes up. It hit the hockey stick. So after many years of working on it, it's really cool to see it's arrived. So
I think the React team counts stars just as galaxies, the amount of stars
Right.
that
Yeah.
That's
But
awesome.
for those
go
that
ahead.
don't know, it's just a way to install tools that doesn't require a package manager and is platform independent. So it can work in Docker, Ubuntu, Alpine, Mac, BSD, and Windows.
How do you find
for
it?
Many of the tools. It's webinstall.dev.
Okay. All right, I am going to throw out my picks, and then we'll let Satya and Joe put theirs in. So I'm going to do a pick. This is a kids game. It's a Grandpa Beck game. I don't know if y'all are familiar. No, it's not. I thought it was, but it's not. Because I'm looking at the artwork for the box. Anyway, so every year for Christmas we get the kids, each of our kids, a game, a board game or a card game. And this one's called Sleeping Queens 2. So I think I picked Sleeping Queens in the past. It's one that, we got for my daughter when she was like 6. And it's a really simple game. You can play it in like 15 or 20 minutes. I think you can play it up to 5 players. And essentially what you do is you play different cards. And in Sleeping Queens, what you're doing is you play the kings to rescue the queens, and in Sleeping Queens you play the queens to rescue the kings, and then you have different cards that let you steal cards from other players or play extra cards or draw extra cards or things like that. So it's really, really simple game. And it's published by Game Right. So anyway, it's a fun game.
Our family loves Sleeping Queens.
Yeah.
Haven't gotten number 2 yet, but thanks for the recommendation.
Yeah. So board game weight, I always throw this in. I don't know if anybody cares about the board game weights, but it gives people a flavor of how complicated it is. It has a weight of 1.5. So, and it's a kid's game. So it's a simple game. It has just enough complexity to make it interesting without making it overwhelming for a 6-year-old or an 8-year-old. So I'm going to pick that for my board game. And I'll post the Board Game Geek listing here. A couple of other things that I'm going to pick. So my wife and I are about to finish up Star Trek Discovery. We've enjoyed the show. I think, and I feel this about a lot of shows, but the first couple of seasons were better than the last couple of seasons. But I mean, the show's been good show. So I'm going to pick that. And then the other thing that I've picked up, I think I mentioned that I've been using Finch, which is just a kind of self-care social app. My wife and kids all picked it up. And so then I can send them hugs and I can keep track of my habits and stuff like that in it. But one of the things that I picked up about a week and a half ago is Duolingo. And a lot of people know what it is. It's free, right? I mean, it shows me ads periodically, but whatever. But it lets you practice languages. And initially I picked it up because I've been wanting to learn Japanese. And so I picked it up for Japanese. And then I can't remember what it was that inspired me, but I was like, I really kind of want to pick up French again because I took French in high school. And so I added it. And then I was talking to somebody else and I mentioned that I had lived in Italy for 2 years and realized that my Italian's gotten fairly rusty. And so I basically do 3 lessons a day. I don't do them all at once because I don't want to confuse my brain. But, I'll do one in the morning and then I'll do one sometime during the day. And then I'll do another one, in the afternoon or evening. And I'm finding that the Italian's coming back to me. And what's funny is that my Italian vocabulary is very strong in a couple of areas, not very strong in a bunch of other areas. Because when I lived in Italy, I was a missionary for the church. And so my religious vocabulary is fairly broad, right? My day-to-day living vocabulary is okay. And then my vocabulary on all kinds of other things is just almost non-existent. And so I've been picking up vocabulary and learning how to talk about things that I haven't really talked about in Italian. So that's been very fun. And I'm kind of at different levels on each one, but it's easy. Anyway, I've been very happy with Duolingo. You can get a Duolingo Plus or Pro or whatever. And if you make a mistake, you get a penalty and you lose a heart, and then you have to wait for the heart to come back. And if you pay, you don't have to do that. And it doesn't show you the ads. And I think there are some other social aspects that it adds. But anyway, I've been pretty happy with it. I'm happy that it's free. And so I can order 4 things in Japanese at a restaurant. I can carry on a very rudimentary conversation with people in French and then yeah, I'm learning to talk about daily habits like exercise and stuff in Italian right now. So anyway, I'm gonna pick all of those and throw it over the fence to Satya.
What's the context for the picks?
So
I'm
it's
guessing.
just a shout out about anything you like, right? So, Dan picked a movie, I picked a TV show and an app. AJ picked webinstall.dev, which is more text, just whatever.
Cool. Yeah, I guess I can do like a sport themed one. So there's right now, I don't know if anyone's familiar with the game called cricket. I don't think it's I don't know if it's popular in
American.
I know of it.
I've
know
heard of
it's a
Same.
sport that can last a couple of days.
right. There are different versions to it. There's one that lasts for like 5 days. There's one that lasts like the entire day, and then there's one that's like a couple of hours long or like 4 hours long.
Right.
So there's a World Cup happening for that, for the really short version. It just started this weekend, and it's happening in the US. I think they're trying to like make it more popular in the US. So I'm like excited to see how that pans out. I was following the last World Cup, which was the slightly longer one that happened last year. And I'm from India, and I was supporting India. And India's generally very good at this game. And they went all the way until the finals, and then they lost, which is very heartbreaking. So I'm hoping that they win this time. So yeah, that's my pick. And then I guess also another sport related one is the Euros are starting next week. If you're into football,
now you're speaking my language.
Yep.
Well,
You mean football, not football.
As long as we're there, I don't know if it'll come out before the show is aired or after, but the NBA finals are also happening.
Right. So I'm in London, so I have to support England for the Euros. I'll be rooting for England.
Have to.
They are also very good.
They are very good.
Yeah, so those are my picks.
I mean, I can't talk. I always support Italy. In the last few years, I've been very, very disappointed.
But England never actually wins, as I recall.
That's true. They went to the finals, and Italy won. Yeah. All right.
Good deal.
Joe, you're up.
So sticking with the theme of the podcast, for those who are curious about compilers, Bob Nystrom wrote a great book called Crafting Interpreters. It is available in dead tree form, in electronic form. It's also, I think there's a free version on craftinginterpreters.com. It's just a really, really great accessible book where he basically walks through building an interpreter for a simple kind of imperative language, very JavaScript-like language. And he kind of walks through building a sort of AST walk interpreter in, I think, like Java, and then he does a bytecode-based interpreter in C. And I don't know C at all. I can just barely read it and know what's going on. And I found it like completely accessible. It's just very, very obvious what's happening. So highly accessible book to kind of understand the basics of what's happening in the compiler and an interpreter.
Well, now we've got to mention the Dragon book if you want something that's totally inaccessible.
Right. Yeah. If you want something inaccessible, I've never bothered reading the Dragon book. And then I'll also give a shout out to Satya has an amazing blog, and he's actually written about some some of the details. Is recompiled.dev, right? So check out Satya's blog for kind of some more details about how the compiler works on the inside. My life is basically the compiler and then like being a dad. So plus one to Sleeping Queens as a pick.
Sorry, I had to find my mute button. All right. Well, I guess one last question is if people want to learn more about what we talked about with the compiler, or, maybe they're looking for Joe or Satya on the Twitter, where do they find you?
So I'm on Twitter as en_JS. And for the compiler, you can go to react.dev/learn/react-compiler.
And I'm underscore _Gsatya on X.
Oh yeah.
Awesome. All right. Well, thank you both for coming and talking through this with us. We kind of had to figure our schedules out, but it's so fascinating. So yeah, I'll encourage folks to go check it out. Until next
Thanks
time.
for having
so
us.
excited.
Thanks, Al.
I'm so excited
thanks for
about
having
this.
us.
Right. Yep. All right.
We
Hang tight for a minute.
appreciate it.
Don't jump off.
Bye.
It's I hit end stream, but it's
Still
I'm
streaming.
gonna hit